In the last video, we took a look at how we could construct this line of best fit. And in this video, we want to take a look at some of the ways that we can try to use this line of best fit now that we have it. One of the first things, though, that we want to try to make sure that we understand about this line is that it can be used to help us make predictions about the variables that we have in play here. So we have something like the weight of a car, and it's somehow being connected with highway miles per gallon. We're thinking that there might be a relationship here, that if I know maybe the weight of a car, I could maybe try to predict the miles per gallon of the car. Now, if I take a look at the diagram that we made last time, we can see this general downward trend. It looks like as the weight of the car goes up as I move to the right, the miles per gallon continues to go down. And that even seems to maybe jive with our intuitions. But of course, I'll notice here that we only looked at 10 cars, so I don't really have the ability to understand what every car is going to do, but the line can help me kind of fill in the gaps when I don't actually understand something. So you can see here that like maybe if I had something like a car that weighed somewhere around this many, I don't know, whatever number would fall on the axis over here, but this many pounds, I could use my line to try to predict the miles per gallon. One of the restrictions, though, that I have to make sure that I'm careful of is to understand that in my data, there was kind of a furthest left data point, like a data point with the smallest x, and a data point with the biggest x that would be furthest to the right. And ultimately, these will kind of create like a gigantic wall that I can kind of imagine on either side of this particular picture that I have. And so what I want to make sure that I see is that what I want to use my line for is to try to predict what's going to happen with data points that exist between these extremes. I would never want to test data values that are bigger than my biggest value over here, or smaller than my value over at the very left. This creates what we refer to as a restricted domain. If I was to take a look at the restricted domain of my equation, that's going to tell me what x's I'm allowed to actually plug in here. So in this case, the restricted domain of our line of best fit is always going to be all x values that exist between my x minimum and my x maximum. That is my smallest x and my biggest x. So in this case, if I was to go back up and look at all of my different weights of cars, all my different x's, I could ask, well, what's the smallest x? And if I glance through that list, I might be able to see that 2,526 is my smallest number of pounds. And my biggest, I believe, is that 4,367 pounds. So when I make predictions, I want to make sure that I'm only picking values of x that exist within this range. If I get a value of x that's outside of that range, it's not really appropriate to plug it in. So take a look at part C. What would my line of best fit predict for highway fuel efficiency if I came across a car that weighed 2,948 pounds? Okay, so notice this right up here is a value of x. So I'll state that we have an x that's equal to 2,948 pounds, and we want to predict what y is going to be equal to. So specifically here, we're going to go ahead and use our formula y hat. And in that formula, we're going to plug in 2,948 wherever we see x. Notice that if I was to do this, I'm going to get a formula that looks like the following. In place of that x, I'm just going to put down my 2,948. And I could actually go right to the calculator and crunch this out so I can get an actual value. So let's see, I'm going to go and I'm going to click on what was the number that I needed here at 34.7359 minus 0.0046 times 2,948. And I'll get a prediction for the highway miles per gallon, 21.1751. So here I can go ahead and state that this comes out to be 21 point, 1751. So 21.1751, and that's a number of miles per gallon. So by plugging in an X, I can get back a predicted Y. Now, I don't know if this is an accurate guess or an inaccurate guess. I don't really have any way to determine that, but it is my best guess because it comes off the line of best fit. Now, if I actually had a car that weighed 2,948 pounds, it might get more, less, or exactly the same amount of miles per gallon. I don't know for sure. But if there was a value, or if there was a car that weighed this many pounds, I could figure out how far off my guess is from the actual miles per gallon. And that's exactly what part D is going to ask us to do. I'll say, notice that there was a car that was actually in the sample that actually weighed exactly 2,948 pounds. In fact, we can see that's this car right here. It's that first car, right? That one actually weighed the appropriate amount, just like what we were looking at over here. And so we don't have to guess the miles per gallon for a car like this. We already have the miles per gallon. And we can see that that miles per gallon should be 23. And we guessed it would have 21. So we were off. So if I want to compute, again, the residual associated with this car, remember that that's really easy to calculate by what we saw a couple videos back. What we want to do is take our observed Y, that is the one that comes out of the table, and we want to minus the predicted value of Y. So in order to do that, I would just take 23, that's what I observed. What I predicted was 21.1751, and if I crunch that out, I'll get a difference. I think that difference comes out as 1.8249. So that's the difference in the miles per gallon. And in fact, I'll even just write a quick interpretation of what this means. I'll just say that this means that the car that weighs 2,948 pounds got 1.8249 miles per gallon more than what we predicted. Right? Just kind of telling us how far off our prediction actually was. And sometimes that's going to happen. In fact, most of the time, we're not going to always guess perfectly right, but we want to maybe be able to understand if I have an observed Y, how far off was my actual guess? Notice I can continue to do things like this. Can I predict the highway miles per gallon for a car that weighs 3,000 pounds? Okay, well, again, the first thing I want to check is 3,000 an acceptable X value that I can use to plug in? Remember, I always have to plug in values that are bigger than my smallest X and smaller than my biggest X. And it feels like 3,000 is going to fit perfectly in there. So I'm going to be able to go ahead here and just write my Y hat. When I plug in my 3,000, that's just going to look like, again, my 343759 minus 0.0046 times 3,000. If I was to go ahead then and actually crunch this value out, I ended up with something like 20.9359 miles per gallon. Hopefully you were able to confirm that you get the same thing. So if I was to ask on this question, can I find the residual for how far off my guess is from the actual value? I would find that that's extremely difficult to do. It's actually impossible to do here because if I look back at my table, I don't have any car that weighs precisely 300 pounds. So I can't kind of like check to see how far off my guess is from the right answer. I don't have a right answer at the moment. Okay, what about part F though? Should the model, that is my line of best fit, be used to predict the highway fuel efficiency for a car that weighs 4,500 pounds? Okay, well again, the first thing I would check is this weight actually an acceptable weight to use? It's got to fit inside the range. And I can see it's definitely going to be a larger weight than my max of 4367. So I can definitely say here, no, 4,500 pounds is too large. It exceeds the max weight of 4,367 pounds. So I could go ahead and plug in 4,500, like just like I did with 3,000. I would be able to get a number back. But what we're saying here is that I shouldn't really trust that number. If I don't plug a number that's inside that restricted domain, the result I get at the end should not really be trusted. It's not maybe a good prediction. There's no good way to know if it is good or maybe if it is bad unless I get something glaringly obvious. Okay. So we'll pause this video here or stop the video here. And in the next video, we'll take a look at parts, uh, or we'll take a look at this, I guess, labeled number 1 here, and talk about how we can actually interpret the values of the slope and the y-intercept of our line of best fit.